Number 175 in your classwork for reciprocal functions and its transformations. We have a function g of x, which is equal to negative 1 over x minus 2. So to graph this, we're going to create an x and a y chart here. So we have values for x that we select and values that we get for g of x that we're going to plot. So for negative 1, we get 1/3. For 0, we have 1/2. So this is our y-intercept. So we have y-intercept at 0, comma 1/2. Now we have 1, 1. At 2, our function is undefined, so we have a vertical line at 2. At 3, we have negative 1. 4, we have negative 1/2. And we can continue to 5, so that'd be negative 1/3. And we can make out the shape of this graph. So it's going to lay along the x-axis and move up towards positive infinity, approaching this vertical asymptote. And then on the other side of the asymptote, we're going to come from negative infinity and come through the points and lay along the x-axis. So we have two asymptotes. We know that when we approach negative or positive infinity, if we select very large values for x, we get g of x is almost close to 0. So that means that we have an asymptote at y equals 0. So we have 1 and y equals 0. And this other one, where our hole occurred, at x equals 2. Our domain ranges from negative infinity to 2 because of our asymptote, and then continues on from 2 to infinity. Our range stretches from positive infinity, or let's go from negative first. So from negative infinity to 0. Then because of our asymptote, so we stop at 0, and then we continue from 0 to infinity. And now we look at our symmetry. So if we had even symmetry, then across the y-axis, our function would be symmetrical, so it is not. And if we had odd symmetry, then we would have a rotational symmetry. So if we rotate it at 180 degrees, it would map onto itself, but that does not occur either. So we have neither for our symmetry.